right, so we're starting a new unit, and with this unit, we're transitioning from using proportions and comparing a sample proportion to the population proportion, and we're moving towards looking at the sample mean and the sample standard deviation, and inferring what it could possibly mean about the population mean and population standard deviation. And something I want us to think about is, first of all, look at, so remember when we started last semester talking about distribution and the normal curve, we were talking a lot about center, spread, and shape. And something to think about in our last unit when we were doing, population proportions, it was for kind of categorical units, right? Like how many people feel this way, how many people feel that way, right? Like it was the response, to your surveys that we did 2 units ago were about, were not something that you could like, I mean, we quantified it by saying how many people, felt that way, but people answered with saying how they felt, what they wanted, what they identified as. So just something to look at is look at how the spread, right? Look at the and this was not even when we're comparing two populations, but uh, look at how we go from something like this to now something a little more simpler, right? And just as a reminder, right, when we talk about the sample, we're going to use things like X bar and S for the standard deviation. And then when we talk about the population mean and the population standard deviation, we're going to use more of the Greek letters mu and sigma, right? So just a reminder that there is a difference in the notations that we use when we're talking about that stuff. So what we're going to do now, what we're transitioning to now is when we take a sample, we're going to make a probability distribution of what the population could look like, for what's the possibility that the sample and the standard deviation are they the same for the population, right, from our sample. And what we call that is we call that the sampling distribution of means, right? So all the possible different means. And we're going to use standard error and what we have been using. Now, remember that when we talk about, samples and things, we think about three things. We think about accuracy, which is bias. We think about precision, which is our confidence intervals, right? Right? That's the mathy things that we do to measure our data. And then probability distribution is when we think about the central limit theorem, right? Which allows us to use the normal curve and allows us to analyze our data using the normal curve, right? Those three things we're going to keep in mind. Now, something that's nice about when we work with sample means versus when we work with sample proportions is the sample mean is an unbiased estimator of the population mean if it's collected randomly, usually. So, it's kind of nice to work with that. Now, the standard error is right. We're going to use that for our precision, right? And we're going to take the sample size, which is n. And we're going to take the standard deviation, right? And that's how we're going to calculate the standard error. But for this week, what we're going to do a lot is we're going to review things that we learned about means and standard deviations from previous units. So the distribution of the scores on a certain exam is n parentheses 70 comma t. N stands for the normal curve, right? The function normal curve. 70 is your mean. So the first number is your mean, and the second number is your standard deviation. Okay. So what this means is that the mean was 70 on the test, and the standard deviation was 10 for the entire population of this class, right? Now sketch the curve and label on the x-axis the position of the mean plus or minus 1, 2, 3 standard deviations, and find the probability that that you would get an 80. Okay. So what we're going to do is we're going to first open up Word, and we're going to just draw it. So the first thing that you have to do, right, is remember it's always going to look like this if we're doing n, right? So that's n, right? We fulfilled that, and now we just have to do 70 and 10. So I'm going to do this in a different color. Always go in the middle, and that 70 is going to go here, right? Our mean always goes in the middle. And that 10 tells us what to add by. So plus 10, 80, plus 10, 90, plus 10, 100. It also tells us what to subtract by when we go to the left side. So 60, 50, 40. Then what we're going to do is we're going to go to 80, and we're going to shade it because they want 80 or higher going that way. But to find the actual probability, what I'm going to do is I'm going to go to my calculator, and I'm going to hit second, distribution, normal CDF. And remember, C stands for cumulative. So now lower is going to be 80 because the lowest we want to get is an 80. And then for upper, we're going to hit 1, second, E, 99. By the way, second is blue and E is in blue, so that's why I need to hit second first. And all that's saying is, if we go back to the picture, is start at 80 and keep on going, okay? Because that E stands for exponent, and so it's really 1 times 10 to the 99, which is a really big number. 70 is your mean, and 10 is your standard deviation. Paste. So 0.158, I write 0.158. And as a reminder, right, we go 1, 2, right, that's the 100th place. Put a line through, this is the 1000th place. If it is greater than or equal to 5, we're going to add 1 to this. And it is, so our answer is 0.16 or 16%. So there's a 16% chance someone has an 80 or higher on this test based on this normal distribution. All right, next one. Several times during the year, the U.S. Census Bureau takes a random samples from the population. On such survey based on a large sample of randomly selected households, right? So we know that this is a sample. Estimates the mean of retirement income in the United States to be $21,201 per year. Okay. Suppose we were to make a histogram. Okay, so this is the important part. We were to make a histogram, all the retirement incomes from the sample. Notice how it says we're not inferring about the population. Notice how it's saying that we're just going to take, we're not, like, it's interesting. They talk about getting this number, but if you unpack the next sentence, it's saying don't worry about this number. We're going to just take how we got this number. We're going to take all those houses, right? And we're going to put their income into a histogram. Would the histogram be a display of the population distribution? Absolutely not. This is a sample, right? It says so right here, sample. So population distribution is for the entire population of the United States. The distribution of a sample, yeah, that is the distribution of a sample. We were to make a histogram of all the retirement incomes. So this is what it is. Let's see what's the next one. Or the sampling distribution of the means. Okay, sampling distribution of the means is what we're going to do next week. And what it is it's identifying that interval of where the mean for the population could be. So the answer is distribution of a sample. All right, so that's it for the intro lesson. We're going to do a bunch of practice problems that are going to look a lot like problems 1 and 2 for the rest of the week. And then next week, what we're going to do is we're going to learn about making a sampling distribution of means using standard error. Okay, make sure to keep in contact with me if you have any questions. You guys are doing really great. I'm really proud of you.